ladies and gentlemen, we'll start with the final session. This is session 7, ICT related technologies and applications. My name is Ashwin Sasongko from Indonesia, and I will chair this session 7. We have 3 speakers. One is Mr. Hana Arisesa. Second is Mr. Hana Arisesa from BRIN Indonesia, and then we have Mr. Boonchai Ngamwongwattana from Thailand, and the third one is Mr. Hammam Riza from KORIKA Indonesia. Can we start with the first session? And for the speaker, we will have 12 minutes for presentations, then 3 minutes of question and answers. After 11 minutes, there will be one bell ring, and then 12 minutes, there will be 2 bells, and 15 minutes, there will be 3 bells. Okay, Mr. Hana, please start the presentation.
Okay, thank you. Good afternoon, everybody. It is an honor for me to be here. Thank you for the committee who invite us for one of the speakers today. On the behalf of Dr. Yusuf Wijayanto, he is our principal investigation in this research, but unfortunately he is on the duty, so I will replace him in these sessions. I am Hana Arisesa from Research Center for Telecommunications, National Research and Innovation Agency BRIN Indonesia. Today I would like to talk about the investigation wireless microwave propagation characteristic 5G and beyond in the ASEAN region. So this is our background. Today, there is a gap between developed and developing countries, especially to build innovation and research capabilities. But there is chance to change that. Every nations should be increasing their capability in research and technology, especially for reaching their Sustainable Development Goals (SDG). According to UN, that SDG 10 and 11, such as to reduce the inequality among the countries, between developed and developing countries, and to make cities and human settlement inclusive, safe in the future, better and better. One of the possible good technology in the future is wireless telecommunications. So today, wireless telecommunications technology is still growing very fast, approaching a new technique and new technology. 5G and beyond, more higher and higher frequency. There is more complicated, and there is more different aspect. So in the ASEAN regions, what is the ASEAN region will take part in this new technology? So I want to emphasize for the uniqueness of ASEAN environment as challenge for future wireless technology system. As you know that ASEAN's maybe have it has maybe 600 million inhabitants, various land topography, different topography, different propagations, and has many extreme temperature, rain intensity, durations, tropical forests, and many natural disasters. So this is our capability to show the uniqueness of ASEAN's conditions. What about the current technology in wireless technology in ASEAN? Maybe in case of Indonesia, we're currently discussing about a 5G technologies and open runs is already running in Indonesia, but we are still discuss the regulation and recommendation, so on and so forth. So the uniqueness of ASEAN environments to be explored for the sake of future wireless implementation in ASEAN's in general and the world in general is very important. So this is based on our objective, this is our target. First of all, to provide propagation loss data in various environmental conditions in ASEAN for the establishment of the future wireless generation in ASEAN, maybe focus on a millimeter wave band and maybe in sub-terahertz and maybe a more and more higher frequency. And the second is to exchange, to share the ability of propagation research among the ASEAN countries and in Japan with mutual cooperations, and to provide useful research data for better decision-making process for triple helix stakeholders. I mean, for the government, for the business side, and for the academics community. And the last is to increase engagement of triple helix stakeholders for establishing research on wireless technology at local and regional systems. This is our proposed methods. The uniqueness of environmental aspect in ASEAN regions has many parameters, such as land and topography, and how we can do the scenario to deal with the measurement of these propagation data, line offset, non-love offset, MIMO, outdoor and indoor scenario we can apply to measurement this data, and what are the phenomena should we address the effect to the wireless communication system. Of course, existing available data in the some part of the world, Europe, US, and other parts is already published in several communities, and also international body standard like IT, UIEEE, FCC also have their recommendation and standard itself. But we can do more measurements about our conditions, uniqueness condition in ASEAN regions. So we can do also simulation to verify this data and this model. So we can plan our measurement, our simulation, existing data in this, and already published standard and recommendations. We can more get understanding about our uniqueness data, our uniqueness conditions data, especially in propagation data for the wireless telecommunication technology in the future. What is the uniqueness of environmental aspect in ASEAN regions? Of course, there are many uniqueness in our countries, in ASEAN countries, such as maybe every year several countries occur wildfire, and in Indonesia and some other parts, and the topography itself, we have a valley, we have mountain, we have marine, we have peninsula, and so on and so forth. And so river city, marine city, needs to be addressed. What's the effect on the wireless communication systems, especially for 5G and beyond? The world is getting hot and hotter today. Extreme torrential rains occur in the tropical countries. Maybe it has effects to the performance of wireless communication system. So this is our proposed method. We can do a measurement and simulations, both simulation and measurement and simulation as well. This channel sounding is a famous method to do propagation measurements data, but lately UAV like drone and something like that is getting more high attentions to be involved in the wireless communication system. We can mimic many drones for transceiver and receiver itself. So in other part, we can do a simulations using license or maybe open source software. We can make more parameter like using many methods, ray tracing, foliage effect, terrain, and so on and so forth. We can verify with measurement and the simulation itself. This is one of already existing experiment for myself, existing experiment in the wireless propagation data, mimicking precipitation in various intensity at 300 gigahertz frequency. So what is the impact in this proposed research? First of all, the scientific and technology impact. So we expect the participation of in academic forum, local and regional and international conference, as well as publication in reputable journal for each participating countries. And we try to provide open the data sets about our uniqueness condition in ASEAN region for the sake of triple helix stakeholder, from the agency, from the policy, from the business, and for the academic institutions, and promoting ASEAN IVO in an academic engagement in research and wireless technology research. So we need more collaboration and new and maybe more and more collaboration in this topic research, because we need more participation for researchers in ASEAN countries, achieving transfer knowledge, visiting researcher, and sharing the data, sharing the analysis to get more and more understanding our uniqueness ASEAN conditions for the future wireless communications. So we can also contributing to improving research and innovation potential at a local and regional level, creating and maintaining a regional research group, especially in the propagations data research. And the last is very important is the policy. A study and recommendation for authority in each our country or maybe in regional countries for the future implementation of wireless technology through a better science-based policy. And then what is the next, our output and outcome. There are three impacts in the output and outcome. First of all, the scientific, and the second is societal, and the last is collaborative. For scientific, we need more and more increasing expert on the wireless propagation research among ASEAN researchers, which is maybe in my view is still not very much. And accessing the propagation characteristic data for unique environmental condition in ASEAN regions. And maybe we can develop a new propagation testing method for challenging environmental condition according to ASEAN situations, such as using UAV drone for the certain and critical conditions, such as disaster, natural disaster, earthquake, and ruined building, and so on and so forth. And about the societal output and outcome, the data set of propagation characteristic of the target environment in ASEAN can be provided in this research. And research study report of the propagation data for authorities. And for the last is a collaborative. We need to increasing participation ASEAN researchers in international, regional, and local scientific events, such as conference and journal at the wireless technology research for each participating countries. So this is the conclusions. What is our target? Our target is to research, to investigate, and to investigate the propagation characteristics data based on the uniqueness of environment aspect in ASEAN regions for the implementation future wireless technology system. What is our methods? Our method is combining both a simulations design and experimental approach, and verifying with existing data and published standardization and recommendations on various aspects of target environmental system to develop open data set of the propagation characteristic for future wireless system. And the last is scientific and societal impact is to contribute the important data sets in various unique environment of ASEAN regions, and participating scientific wireless community, and supporting is very important, is supporting national strategic mission and policy on the implementation of future wireless technology in ASEAN, and engaging local and regional triple helix stakeholder to increase technology sharing knowledge for better human development capacity in ASEAN. This is last call join for collaborations. The candidate collaboration is Dr. Yusuf Wijayanto. You can contact him, and we can contact me as well. We can discuss after this or later on. And Prof. Sevia Idrus from UTM Malaysia, and Prof. Ashwin Kanu for Nagoya DBT Japan. Thank you very much. Thank you very much.
Thank you. Thank you, Mr. Hana. Any question from the floor, please?
Yes, please.
Yes, please.
Okay, so thank you very much, Mr. Hana, for a nice idea and also some purpose. Actually, I did this research in 2019 and made publication in IEEE, and we call 5G Indonesia channel model, and we made experiment for Java Island, and then this year we are making for Sumatra Island. So your proposal here is to extend for the ASEAN, and then maybe, yeah, maybe this is also a good idea. We can have ASEAN 5G ASEAN channel model maybe by doing this. But yeah, from the scientific view, this is very good. But I think we need more than that. We need more than just 5G ASEAN channel model. But we need, what is the impact of knowing the ASEAN channel model to the economy, for example? For example, this is very interesting if you can make connection between what is the best bandwidth used by each ASEAN country such that it increase the economic level for the countries. So would you please give the comment for that purpose? Thank you very much.
Thank you very much for the questions. My response is research on the wireless propagation data is not a simple research. I think we need more and more collaborations, especially for the scope of ASEAN. So why we are right now here, we try to join for all the participants to build our idea and joining for the next level of propagation data. So there are many constraints in propagation wireless communication system research that maybe we can discuss more later on, because I think it's not trivial research, but we need to support for other ASEAN country. We need more discussions about this. So this collaboration, a big collaboration for sake for the future ASEAN system and conditions. Thank you very much.
Thank you, Mr. Hana. Because already time finished, and yeah, I think we can discuss it outside, Mr. Abu. Next speaker will be Mr. Boonchai Ngamwongwattana from NICT.
Hello, everyone. My name is Boonchai Ngamwongwattana. I'm working at National Electronics and Computer Technology Center, or NICT, in Thailand. My work, the title of my work is Automatic Service Recording System using Network-Based Monitoring Approach. Okay, some background about the work. This work is a collaboration between NICT and Thai Telecommunications Relay Service, or TTRS. TTRS is a public organization offering video relay service, usually called a VRS. It's a service to persons who are deaf, hard of hearing, or having speech difficulties. The organization was founded under the USO, or Universal Service Obligation, which is a fundamental consumer protection policy in most countries, to ensure that everyone has access to telecommunication services. With 4G and 5G communication, VRS users can make a video call to the center, and the agent, who is a sign language interpreter, will help to place a call and relay the conversation to any person. The VRS service is very efficient and most preferred by the deaf community because the flow of conversation is much more quickly than the text-based relay option. The goal of this project is to record and archive video relay services at TTRS. There is needs for this, for example, for service evaluation, verification, improvement, interpreter training, and examination in case of appeal. The existing workflow is not very efficient because the agent has to involve in the process manually, which has an impact on the workload and efficiency. The target of this project is to make the whole process fully automated, so the agent can focus on providing the BRS services. The process must also be intelligent to be able to identify the caller, type of services, and collect and save the detail of the corresponding services. In our proposed method, we propose to use the network-based monitoring approach to capture network traffic. The system will analyze network packets, call signaling, and related protocols. Call signaling is based on SIP and SDP protocols that normally used in voice over IP. We can detect call activities, collect call information and details. The audio stream and video stream are based on G711 and H264. There are a lot of details on how to handle these type of payloads, and I put the references here. The RFC 7655 for the audio and RFC 6184 for H264 encoding. Then the system will reassemble relevant media streams and create raw audio and video files. These files are then edited and recomposed to create the final video file that capture the whole VRS conversation. The video files and call details are automatically uploaded to the cloud storage. This is an example that the system can analyze and visualize the call signaling and media streams with details. On the left, you can see the caller who make a video call. You can see the signaling media streams. There are two for the audio, go forward and backward, and two for the video, go forward and backward. And on the other side, on the right, the agent helps to make a cell phone call to a phone number. And there are two audio streams on the right side. And the implementation of this work is based on Java. We use PCAP, the very popular library, the PCAP, packet capture and FFmpeg library. The challenge is how to process many real-time interactive multi-flows of media streams. The optimization is vital. The processing must be swift in time without causing the buffer overflow. We propose a new methodology called multiple buckets, as opposed to traditional single bucket. On the image on the left is a traditional single implementation of PCAP. On the right is the multiple bucket PCAP architecture. On the left, usually we have only one instance of PCAP. On the right, we try to create necessary PCAP instances dynamically to be able to handle a lot of traffic faster. In our experiment, we monitored the input, the output rates, and utilization of PCAP buffers. Output, see from the table, output rates are slower because time spent in the processing, and also that also causing the buffers to build up. Going down, you see call duration, as longer call durations need more buffer. However, normally PCAP buffer is limited. We assume that we don't want to change or modify any PCAP library. We use any PCAP that you can find in the open source. The experiments showed that multiple buckets can reduce buffer utilization around 65%. Look at the column for the buffer utilization on the green compared to utilization on the blue column. It's lower. This is the output. Image on the left is the agent who provides VRS services via cell phone-based application. The caller, in this case, is a Grab rider. He needs help to contact a person to deliver food. The caller makes a video call in. On the right side is the application that we developed. The recorder detects a signal, the call coming in, and it starts recording automatically. The recorder continues to record while the agent makes an outgoing call to a third party. And this is a recorder portal. It's a web-based that gather all the details information, allow the admins to easily monitor the VRS services. You can see there's a column for date and time, the caller, the agent, and the service. In this case, it's VRS that make a call to other phone number, and the admin can click on the to play video, can search and play video in sharp and native resolution. In compared to normally when we use the cell phone. Can I go back? Oh, usually when we do a cell phone, we can see that we have a smaller video for ourselves, but it's very hard to see the sign language. When we do record using network-based, we can gather the video in sharp and native resolution. And in conclusion, in this work, we presented our R&D project under cooperation of NICT and TTRS. TTRS provides video relay service to persons who are deaf or have speech disabilities. The project goal is to record and archive VRS services for evaluation, improvement, etc. The important thing is the whole process must be fully automated and intelligent to be able to record and the relevant video and phone calls among the parties. We proposed the network-based monitoring approach, which can automatically detect the calls, analyze video and audio streams, create video files of the VRS services. The project helps to reduce the agent workload. The agent can focus on the VRS services to the callers, and the overall efficiency and utilization at the TTRS are improved significantly. And finally, this work can be connected or extended in other projects as well that involves network traffic capture for analytical processes. And that's the end of my presentation. Thank you for your attention. Any?
Thank you for giving more time for questions.
Okay, any questions?
So we have a lot of time of questions, so please, the floor can give the questions. Anybody would rise? Okay. Meanwhile, can I ask short question? Is your system for the automated system also include for the TTRS or VRS to have an option? Okay, I do not want to record. this one because it is what call it secret or whatever it is. You do not want to record. It is automated, but I can choose not to record the discussion.
We used to have that option, but it depends on the center. Currently, they want to automate everything, so the agent can focus on the job. But later on, they can choose that this call they don't want to. That there is no need to record. They can delete it later.
Oh, I see. They can delete it later. Okay, thank you. Anybody else? Anybody from the floor? Okay. So if not, then thank you for the great presentation.
Thank you very much.
Yep. Ladies and gentlemen, now we have the final presentation from Dr. Hammam Riza and about the AI and IoT predictive maintenance smart monitoring system. That is about artificial intelligence. Please, Hammam.
Okay, very good afternoon. Greetings to everyone. Last but not least, my presentations finally. I'm quite happy coming back to the ASEAN IVO Forum 2022. After last year, we have it in Telkom University in Bandung. So let me present some of the work that have been done by our colleagues, myself, Rahmat, Darmawan, Noval, Indriatmoko, Sony Alfatani, and Christian Kurniawan. All of us are from the Collaborative Research and Industrial Innovations in Artificial Intelligence. This is an association that was formed after the launch of our national AI strategy back in 2020. So I want to share with you a predictive maintenance that takes data from multiple and various sources. This is something that combines information technology in general, IT operations, and use machine learning techniques to anticipate equipment failure before it happens. So smart monitoring system is a term that we coin that to comprise the overall operation of an IT system. So organizations are facing increasing pressures from growing IT complexity, customer demands, ongoing security vulnerabilities. And in response, we are embracing new strategies that leverage artificial intelligence for IT operations. Thus, we found that So let me continue. So we need to have a new strategies that leverage artificial intelligence for IT operations. And this is where AI operations comes in. This is to automate and improve how we develop and run the IT operations. AI operation is AI and IoT can provide high-level overview of the process, especially in the IT operation, and involved in setting up a predictive maintenance program for any type of high capital asset, whether it is a heavy machinery, fleets of any kind, manufacturing equipment, and especially on ICT infrastructures, data centers, network operations, security operation centers, etc. The smart monitoring system that I coined in to comprise the IT operation is a solution to provide the real-time status reading and a predictive indicator of an infrastructures The key lies in not just simply monitoring the various time series, as you can see in the visualization of this map. We have so many command centers and data centers around Indonesia as part of the IT operations of many institutions, not limited to the government. And coming from this time series data, actually, we can employ machine learning algorithms to take actions for real-time insights. A classification model is developed to predict the state of the monitoring target, whether it is still working or is it in failure status. And the sensor readings are fed into the classification model to predict whether or not the monitoring target will be in failure state in the near future. Using this time series data, it is possible to predict sensors reading using supervised learning method, such as long LSTM and GRU. We have run the simple experiments using this architecture coming from input of IoT sensors reading time series data and historical operations, and coming into the algorithmic machine learning process, where we do the feature extractions and deep learning and output the time series forecasting and classifications. Sorry. Okay. And coming from that, we have from this output, we have the outcome, whether it is descriptive artificial intelligence and predictive AI. We did a mini experiment, I would say, with several IoT sensor readings. The color indicator or threshold can be attributed to each sensors. As you can see in this slide, there is a temperature IoT sensor, acoustic, noise IoT sensors, light sensors, moistures, water level, presence and proximity sensors, as well as chemical IoT sensors. And we run this experiment with limited features here, such as temperature, humidity, voltage, and memory indicator. And coming from this data source, we were able to do the data analytics on this particular patterns, and then created the hypothesis validations to have the data-driven decisions, where we set up the initial threshold value for each sensors and come up with the final model which can predict the sensor readings in the futures. The predictive maintenance scheme can be seen in this slide through two kind of tasks, which is first the regression task, and the second one is the classification task. In the regression task, we did pre-processing, time series forecasting, and a regression model, as well as the similar scheme that we use for the classification, building up the classification model, where then it was integrated into a prediction and decision support. Some example on this particular experiment for predictive maintenance is showing some of the monitoring of several assets here, such as like 46 data centers and 16 radio stations and other security operation center. And the indicator, the blue indicator, shows up the current status and the forecast. Yeah. So this means that the AI operations, which is the umbrella term for the use of this big data analytics and machine learning and other AI technology, is particularly interesting to automate the identifications and the resolutions of the common IT issues. Outcome of this work is ICT system with intelligent predictive maintenance capabilities will be the mainstream in the future operation of various infrastructures, especially on ICT. And combine, we say this as a ABCD plus X technologies, AI, blockchain, cloud, big data, with X such as Web3, communication protocol, sensors, and embedded system, and especially probably forthcoming 5G technology or even 6G, like we are discussing today. Then AI and IoT can accelerate innovation in the development of continuous ICT operations. In conclusion, given the resource spent on maintenance across industry today, predictive maintenance is a critical step in reducing costs, increasing productivity, and ultimately staying relevant in an era where cutting-edge data-driven businesses are gaining market shares. Through the initial cost of implementing a predictive maintenance strategy, which may be steep, companies today are already proving that the returns in increased productivity plus the reduced costs are available returns. AI, IoT smart monitoring system is just a preliminary use cases for ICT operation, and we believe if we move into the smart cities area, smart mobility, and many other use cases where we need to run the operation smoothly, then this kind of solutions can be developed. And to further these collaborations, we need all of you from the ASEAN partners to join hands for the better future. Thank you so much for your attention.
Thank you for the interesting presentation, Pak Hammam. And ladies and gentlemen, if you have any questions from the floor, any questions from the floor? Since AI is the future, yes.
Okay, I think for predictive maintenance or predictive system, normally we use like historical data to classify or to identify existing failures. What do you think how such system can like predict failures that we don't know yet? Because it does happen in real engineering implementation as well. Thank you.
Yeah, good questions. Can I go straight ahead?
Yes,
Well, you're basically right. Historical data is something that we try to collect from a time series data coming out of this sensor. So we built this system of sensors using wireless network, okay, mesh network, and we collect data to actually look at some of the routine process. Routine practice, which include sometimes a user request for such a non-critical IT system. And for example, AI, we can also enable a help desk system to collect this data, because the user probably will sound the alarm for this kind of incident. So in order for us to process and fulfill user request data, this data can also be used as historical data. And then certainly we need data to recognize some of the serious issues of running the IT operation. And usually IT professional might address a known malware event, for example, on a non-critical system. So this kind of insight and data is also used to do some of the predictive maintenance, to formulate the predictive model, using the machine learning and probably some deep learning. So we just use two kind of supervised model at this time, but I believe that, many other models, including some of the latest pre-trained model for AI operation can be also used.
Thanks for Hammam. And there's another 2 questions, please.
Thank you for the interesting sharing, Hammam. You've been talking about this predictive maintenance on a more hard aspect of it, but there is definitely a soft aspect of it to, action on it, risk management of, when the model is failing. Perhaps you can comment a little bit on that.
Yes, you're true. So running the predictive maintenance is something that we want to have as part of the IT service management, ITSM. So if we look on this particular issues, then the IT service management will be improved by having automated service maintenance, automated or schedule maintenance, and it will lower the unscheduled maintenance that happens. We want to be able to mitigate the risk of unscheduled maintenance, and in this case, the IT governance will come in, into this.
Thank you.
Thank you.
Thank you.
Yeah.
We have one last question. Last presentation, last question.
And from my friend.
Yes. Okay. Thank you very much, Dr. Ashwin and also Dr. Hammam. Very short because already bell 3 times. Okay. So speaking about the predictive maintenance and also the explosion of the data, and also when we make connection with this morning keynote about the cloud and also the digital economy, which is also extending into the digital first economy. So some countries are predicting that for the cloud computing, they are trying also to use the quantum computer for the high speed of computation and also the security because of no cloning theorem. So do you think that for this predictive maintenance and also smart monitoring in the future, and also for the ASEAN, we need such kind of very high-end future computation? Thank you very much.
Thank you. Exactly. So I support your actually comment actually in this, that we will certainly need more computing power. We need to have more data set in order for us to explore a bigger data set. That's why big data analytics and AI, as I mentioned earlier, the technology, blockchain, including all the communications protocol, whether it is mesh sensor network or something like that, will be a significant progress in order for us to combine all this for the operations of many automated systems. So it's I think I reckon digital transformation is going very well across the ASEAN regions, and all of us are we are not just a follower of digital transformation. I see many ideas have come up during this day for today with really bright futures for all the research and implementations and innovations in ASEAN. Thank you.
Thank you, Pak Hammam, and we give appreciation for the last presentation on AI.
Thank you.